Hello, today I'm going to be walking you through the BoJack Horseman family pedigree and discuss a few of the possible modes of inheritance. BoJack Horseman is an animated show about a celebrity horse. Mental health is a prominent topic on this show. So here we have the pedigree as well as the phenotype of interest. Note that in reality, depression is not a simple Mendelian trait. Depression is a complex disorder with many influencing variables such as physical health, environment, and access to support. But as you can see for BoJack, depression runs in the family, the phenotype showing up in his grandmother Honey, as well as his parents Beatrice and Butterscotch. Also, you can see that his father Butterscotch was unfaithful and had an illegitimate child Hollyhock, but she does not possess the phenotype. So let's take a look at some of these possible modes of inheritance and discuss their plausibility. First, we can look at Xlinked Dominant. I have marked all the genotypes that the individuals would have to have, and you can see that this is not a plausible mode of inheritance, as Hollyhock would have to have inherited a recessive X allele from Butterscotch in order to not have the phenotype. But Butterscotch is only able to donate a dominant X allele. Now we can look at X-linked recessive. This mode of inheritance is also not going to work. We can see that Crackerjack, BoJack's uncle, does not have the phenotype, so he would have to have obtained a dominant X allele from his mother. But this is not possible, as Honey would have to have two recessive alleles in order to display the phenotype. Note that if you follow this logic, you can see that several other genotypes would not work, such as Beatrice's. All right, and now we can look at the autosomal dominant. This is a possible mode of inheritance, and I've displayed all of the possible genotypes. Note that BoJack's genotype is ambiguous, as he can be either homozygous or heterozygous, as long as he has a dominant allele. And we can then also look at the autosomal recessive mode. This is also possible. Here we can see what the pedigree would look like. Finally, we can look at the Y-linked mode of inheritance. This would not be possible, as several of the females in the family exhibit the phenotype, despite not having Y chromosomes. All right, thank you for your time, and here's a list of references used in the presentation.